Problem number 1. One of the Undersecretary of the Department of Labor and Employment or DOLE claims that the average salary of civil engineer is 18,000 pesos. A sample of 19 civil engineers' salary has a mean of 17,350 pesos and the standard deviation of 1,230 pesos. Is there enough evidence to reject the Undersecretary's claim at alpha level equal to 0.01? Analyzing the problem, we can conclude that this problem is under one sample t-test because the number of sample is 19. Next is the step-by-step process to check if there is enough evidence to reject the Undersecretary's claim. Step number 1 is to identify the null and alternative hypotheses. So let's try to look for hints in the given word problem for us to formulate the null and alternative hypotheses. So in the first statement, it is said that one of the Undersecretary of the Department of Labor and Employment claims that the average salary of a civil engineer is 18,000 pesos. So it is a researcher's claim, but the researcher's claim is that the salary is equivalent to 18,000 pesos. So because of the term na is 18,000 pesos or parang the concept is under equality. So meaning to say, we can say that that statement can be parang a clue for us to come up with the null hypothesis because of the parang concept nga ng equality. That's why the null hypothesis will be population mean is equal to 18,000 pesos. Next is to look for clues and hints in formulating the alternative hypothesis naman. So, from the next sentence naman, a sample of 19 civil engineer salary has a mean of 17,350 pesos and the standard deviation is 1,230 pesos. Is there enough evidence to reject the Undersecretary's claim at alpha level 0.01? So, the term that they used dito sa sentence na to is the term to reject. So, if we just reject, so, ibig sabihin, there's no clue if it is greater than or less than 18,000 pesos. Parang they're just stating na we just reject that 18,000 pesos. So, parang if we are just under the concept of rejecting, the mathematical symbol that we should use is not equal. Kasi, di ba, we just have to choose from not equal, greater than, or less than. Since we don't know if it is greater than or less than, we just stick with not equal. Therefore, our alternative hypothesis can be written as the population mean is not equal to 18,000 pesos. Step 2 is to look for the level of significance, identify if it is under a one-tailed or two-tailed test, and for problems under one sample t-test, there's another variable to look for under step 2, and that is degrees of freedom or DF, and the formula for that is equal to n minus 1, wherein n is the number of samples. The purpose of finding the degrees of freedom is that the degrees of freedom, same with the level of significance and the tail test, will be used to identify the t-tabular. For the level of significance under this problem, it is equal to 0.01 as it is directly stated in the problem na alpha level is equal to 0.01. Next is to identify if this problem is under one-tail test or two-tail test. So same with the step 2 for one sample z-test, we can identify if it is a two-tail test if the mathematical symbol for alternative hypothesis is a not equal symbol. And then for one-tail test naman, if the mathematical symbol in the alternative hypothesis is greater than or a less than inequality symbol. So in this problem, since the alternative hypothesis uses the symbol not equal, so meaning to say this problem is under two-tailed test. Still on step 2, we have to look for the degrees of freedom with the formula of n minus 1, where n is the number of samples. In this problem, the number of samples is 19. So Substituting the value for n, we'll have 19 minus 1. And simplifying, we will have 18. So the degrees of freedom is equivalent to 18. Step 3 is to identify if the given problem is under one sample z-test or one sample t-test. So you have to check if the number of sample is greater than or equal to 30 or less than 30. Because if the sample is greater than or equal to 30, then this problem will be under one sample z-test. But if the number of sample is less than 30, then this problem is under one sample t-test. Checking the number of samples in this problem, it is less than 30, so this problem is under one sample t-test. Step 4 is the computation. In the first sentence, we have the numerical value na 18,000 pesos. And since that this parang sentence explains the salary of a civil engineer, parang of a certain civil engineer in total, so 18,000 is the population mean. Next, a sample of, so we have the term a sample of, so meaning to say the numerical values that will follow will be for the sample in this given sentence. A sample of 19 civil engineers. So from that phrase, we can say that 19 is the number of sample that we have for this problem. Salary has a mean of 17,350 pesos. So we all know that this is the mean since it is already directly stated. And then next, we just have to check if this is a population mean or a sample mean. So since this phrase is still under the sentence in which parang they explain the numerical values under sample, so yung 17,350 is our sample mean. And the standard deviation of 1,230 pesos. So, since this is still under the sentence in which they explain the numerical values for the sample, then this standard deviation is a sample standard deviation. So, sample standard deviation is 1,230. Going back to step 3, we know that this is under one sample t-test. So, we just get the formula for one sample t-test, and that is sample mean minus the population mean all over sample standard deviation over the square root of n. Substituting, we will have 17,350 minus 18,000 all over 1,230 over the square root of 19. The calculator on the left side shows you how are you going to input the values if your calculator is a 4-liner calculator. And the calculator on the right side shows you how are you going to input the values if your calculator is a 2-liner calculator. Using the calculator, the value for the t computed is negative 230. Next, step 5, decision rule. The decision rule is the same with the one sample z-test. It's just that instead of using z computed and z tabular, we have to use t computed and t tabular. So we will have reject null hypothesis if the absolute value for t computed is greater than or equal to the absolute value of t tabular. To show you po, this is the full t-table. This is the table that you're going to use if the problem is under one sample t-test. This is how the table works. In the second and third row po, this numerical value signifies the level of significance for a given word problem. Then, the values in the first column are the numerical values for your degrees of freedom. Then on the upper left corner, we have the one-tailed or two-tailed test. With the one sample z-test, we have to go back to step 2 for us to identify the t-tabular since we already know what is the t computed for this problem. In the previous slide, I already showed you where can you locate the level of significance, the tail test, and as well as the degrees of freedom. So first, locate your degrees of freedom in the degrees freedom column, and then after finding the numerical value, all you have to do is draw an imaginary horizontal line passing through that degrees of freedom. Then going back on the upper part of the table, we have to check if this problem is under one-tailed test and two-tailed test. So if this problem is a one-tailed test, you have to locate the level of significance in the row where one-tailed test is located. And then if the problem is under a two-tailed test, you have to locate the level of significance in the row where two-tailed is located. And since the problem that we are trying to solve is under a two-tailed test, we have to look for the level of significance in the row where two-tailed is located. Next is the level of significance. Our level of significance is 0.01. So, in the two-tailed row, you have to parang locate where 0.01 is and draw an imaginary vertical line passing through that given level of significance. And the intersection of those two imaginary lines will be our t-tabular. That we know the value for our t computed and our t tabular, all we have to do is substitute the given values. Substituting, the decision rule will be reject null hypothesis if the absolute value of negative 230 is greater than or equal to the absolute value of 2.878. Next, step 6. We have to check if we have to reject the null hypothesis or fail to reject null hypothesis based on the decision rule. So same with one sample z-test. If the inequality statement is satisfied or it is considered true, then we reject the null. If otherwise, we fail to reject the null hypothesis. Going back to the inequality statement in step 5, we have the absolute value of negative 230 is greater than or equal to the absolute value of 2.878. So if we are to decide if this is true or false, it is obviously false because if we extract the absolute values in this word problem, it will still be false since 2.30 rather is less than 2.78. So the given inequality is false. So meaning to say, we failed to reject the null hypothesis. Finally, last step, step 7, is we have to draw conclusions based on step 6. Since we failed to reject the null hypothesis, and in this problem, the null hypothesis is the population mean equal to 18,000 pesos. And that mathematical statement refers to the sentence case na the average salary of civil engineer is 18,000 pesos.